Welcome, everyone. My name is Dan Mckeon. I work at OpenZeppelin. We created a popular smart contracts library, probably a lot of you have heard of. We also do security audits, and we also build tooling, and that's mainly what I'm going to be talking to you today here in Security Doesn't Stop at Code Complete. So why does this subject matter at all? We have a big trust problem in Web3 that causes a lot of people that are kind of right on the edge, maybe would be interested in some of the elements, but they see headlines like you see on the right here. There's $1.9 billion stolen in hacks, and we sort of wear it like a badge of honor of not your keys, not your coins, and do your own research. And we kind of put a lot of onus on users, and so everything we can do to try and reduce that. So that does include security audits. It does include coding securely by design, but it also includes what you do in deployment and thereafter, and that's what we'll be talking about today. So in Web 2, where I came from a couple years ago before I was at OpenZeppelin, there's a very robust set of processes that whether you work at Amazon or some little startup, everyone kind of does things in a similar way. So we follow strict CI/CD processes. We do a lot of monitoring, logging. We represent our infrastructure as code, so it's reproducible. We monitor performance, and we kind of automate just about everything we can. And there's a million tools in that space. They've been around for a long time. These are some very popular ones, probably many of you have heard of, some of you are probably using, and there are literally thousands beyond. You see on this list that you kind of hear about a new one almost every week when you're working in that space. So in Web 3, it is highly variable. I think there are definitely a lot of protocols that are more developed, have been around longer, maybe have larger teams that are maybe have more robust processes. But there is also a little bit more of a cowboy mentality in a lot of the space, and that things are a little bit more freewheeling in some cases. So I think in many cases we're doing CI, but CD is more like deploying when someone sends you a Slack message or something like this. We monitor the Discord server, and the deployments are often happening, via some script that the senior developer is firing off. But we do have tooling now, and so some of this tooling has been around for a little bit, but there's been a lot of maturation here in the last year around the landscape of tooling we have available to us, and even tooling that has been around. There's been big improvements, particularly in UX, that have happened here in this last year, and I think a lot of folks who maybe tried various tooling options as of a year plus ago didn't have the greatest experience, that today those tools might look actually very different. So we're going to be talking about a very wide array of topics today: deployment, monitoring, and incident response. We only have like 12 more minutes, so we can only kind of touch the tip of the iceberg here. But here we go. If you want more details, certainly there are a lot of great resources out there. We have a solutions team at OpenZeppelin that actually dives much deeper into these areas. So deployment and upgrades we'll talk about first. We want reproducibility, and especially because multi-network has become so important. So when you're doing something by script, when you're kind of like changing constructor arguments, you're going to inevitably have human error, and so we want to use an automated process. You see the GitHub CI runner here at the bottom. There's many different options for this, but at any rate, when you have reproducibility, and you're able to just kind of change one config to change networks, and you're able to have it that next time you deploy it is the exact same as the earlier deploy, you also have auditability and logging. So if something went wrong, you can fix it at the system level and not have it be that someone fat-fingered like a key in the constructor argument and screwed everything up. Private key management is also kind of a big thing in this world. So there are relay services out there. OpenZeppelin Defender does have one called Relay. There are other ones as well, but one of the benefits of private key management is that if your API keys are compromised, you can do key rotation, where if you have a private key that you're relying on and that address is very important to you and that's compromised in some way, it's a little bit of a different story. Bytecode verification, so when we're upgrading, and especially for non-technical users, because I think technical users are sometimes more diligent about this, but a lot of signers on safes are not necessarily technical users, and so you can use tooling to validate that the bytecode that is in GitHub that you've proven that yes, this is the right bytecode that should be on chain is actually on chain. and enable someone to kind of run that validation for themselves at the point of signing a proposal. And same deal with type safety. And so this is more of a UX issue, but it can turn into a security issue if you upgrade a contract and it turns out you're not being backwards compatible, or you're maybe exposing something you didn't think you were exposing. And finally, testing in lower environments, so fork networks, test nets, and this, I think probably a lot of us are doing to some degree. I just used a tool, by the way, called Conduit the other day that is fantastic for fork networks, deploying a fork network. I highly recommend folks check that out. I think it was a Paradigm project. So in monitoring, we're kind of in a unique place where we have a tremendous amount of data in Web3, and we also have really good signals as to what kind of transaction we can map to an exploit. And so systems that are characterized by those two elements are very, they're great candidates for AI to be a good solution. I don't think AI is a panacea for everything, but when it's got those two elements, it's a really good option for kind of making a system work better than you can via traditional methods. So Forta is a decentralized monitoring protocol. One of their, the set of bots they've built is around machine learning, and there've been a number of instances like this, but I just kind of had one use case here, or one case study of the urine attack on April 13th, where a Forta ML bot fired this alert at 5:29 UTC. Just over 20 minutes later, urine vault's attacked. Leads to $11 million in losses. And so there's a lot we can do with AI. I think that potentially broadly, like I'm kind of describing here, but possibly also at a contract level. And I think that area is kind of just beginning, but it's a big thing to look out for, especially over this next year as we're now kind of gaining this big interest in AI. So it should be taken with a grain of salt, because no monitoring solution is perfect. This attack detector bot I referenced, it does have an 80% roughly recall. That means that of the actual attacks that happened, 80% of them this bot could detect. However, it's only a 20% precision, and so this speaks to the false positive rate. So of every 5 alerts that are fired, 4 of them are false positive. So we can't just, every time a bot like this fires, we can't just pause the protocol. That's not really a good solution. And we'll talk about that more in a minute. But suspicious activity screening like this kind of like generalized approach that I'm talking about, this applies to all contracts, I think this is something that we view as necessary but not sufficient. There is also certainly work that needs to be done based on your protocol. And every protocol is different, and this next section is there's kind of a set of questions here, and these may look very different, the answers to them for each protocol. So this is one that we all think about. Which invariants signal a threat or an active exploit? So if there's a highly profitable trading strategy and you have a lot of value being taken out of your contract, what does that look like? What are the parameters you might monitor to validate that? And then, if you've just made a deployment, how do you know that that's sound? How do you know that that's behaving in the way that you think it should be behaving? What exposure do you have to changes in external dependencies? We make assumptions sometimes like that one stablecoin dollar is going to equal $1, and then all of a sudden, crazy things happen, and then that assumption is violated. And monitoring other contracts where this data is coming from is also kind of part of your security framework. So if there's price oracles or conditions on other networks, like if you run a bridge, for instance. Finally, if your protocol is exploited, so maybe you're monitoring fires, but like that was the hack, so it's kind of too late to fix that now or to prevent that from happening. But even after that happens, what's your action plan then, and how quickly can you execute on it? So that's kind of monitoring is sort of the triggering that is going to lead to your incident response method. And so I mentioned this a minute ago, but pausing at the protocol level is kind of something I think we often think about at a high level, like that's how incident response works. There's actually a lot of other ways you can approach this. You can be much more targeted with your pausing. You can pause based on specific functions, maybe specific senders. You can also like limit withdrawals. You can see something that's highly suspicious and you can set a cap that's like somewhere lower than the 13 million or whatever, and that maybe, in all these cases, you can't necessarily prevent everything. In some cases, you're kind of mitigating the issue. And that way, with false positives, which any type of monitoring is inevitable, if you try and have no false positives, you're going to probably end up missing a lot of the real exploits. And so we use tooling for this, and this is kind of this burgeoning area of Web3 that there are now a number of different options that we have available to us. So I'm just going to show kind of a trivial example here, but this is sort of like roughly how tooling can aid in the incident response scenario. So we have this transaction, and this, for whatever reason, we've determined is a malicious transaction. And like the scenario I just referenced a moment ago, this Forta bot detects it, it fires. It can fire, it can do all variety of things. In this case, it's going to trigger a Defender Sentinel. And then that Sentinel then is going to execute some arbitrary code. So this is JavaScript code we have in an auto task. And what we're doing here is creating a proposal that is, in effect, it's going to do a couple different things. It can send a message to the Gnosis Safe transaction service. And so now you have your transaction ready to go in Gnosis Safe, like the moment after the exploit has occurred, or that there's a suspicious transaction that indicates an exploit is about to occur. You can also trigger services like PagerDuty. And so you need to think about, if this does happen in the middle of the night, how are the developers, whoever's managing this incident, going to address this situation, and how are they going to wake up from sleep and do something in 20 minutes. And so now we have our Gnosis Safe proposal. Finally, hopefully everyone jumps on it. We validated that yes, this proposal makes sense. It's probably a defensive posture where something is, again, we've already gamed this out and everything, and we've kind of made the determination that this is safe, hopefully beforehand, and we go ahead and actually execute it. Finally, this area of after an exploit, there's a wide variety of things you can do. There's a guy named Gall who gave a presentation earlier that was excellent on much more detail of what to do after an exploit, but high level, Chainalysis has an API for this. There are others too, but essentially, like, you have things you want to do on chain, you might want to execute a pause at that point, because there are a lot of cases where attackers will double dip, and maybe it is multiple transactions spread over 10 or 20 minutes that actually take everything, and you want a comm strategy and all manner of other things that go along with having an exploit occur. So 3 key takeaways from the presentation here would be, first, to identify opportunities to replace any manual processes with tooling. And so I particularly talked about deployment, but there's lots of other opportunities as well, probably here, of folks who are running scripts themselves. Develop a plan around your incident response. You probably have a generalized strategy and a number of different scenarios based on what exactly is occurring. And finally, simulate an exploit and test your systems and see if this actually occurs, like how quickly can we actually execute on this. So finally, a few folks who contributed to the presentation, Christian Seifert at Forta, Mike, Casey, and Jonathan at OpenZeppelin were all very helpful in putting together the content. Other OpenZeppelin talks here coming up in the next few days. We got Marto on July 19th and Hadrian talking about the Contracts 5.0 release that we're very excited about. Finally, there is a POAP, if anyone cares for a POAP, and on the left is a link to sign up for Defender. So thank you very much. Sure.
Okay, we can take one question. Anyone?
Quick question on the incident response. When do you think is the right time to keep processes in-house versus bring in, external white hats or third parties to be able to maybe rescue funds or coordinate response?
After an exploit has occurred, you're talking about. I think that, so in terms of like Chainalysis, that is an external service. I do think that probably, it's like a lot of these things, like they're handling a lot of the legwork you would need to build in-house otherwise. So I think using APIs like that probably makes a lot of sense. But teams that are big enough to have like a PR team and so forth, like that's part of your incident response, is you want to get on Twitter, you want to have dedicated people responding to it. So I think there are external entities you want to bring in pretty much right away, but certainly your team would be very involved as well. Thank you.